Hi, everyone, and welcome back to iMvision's executive education program, Rethinking Application Security in the API First Era. Wherever you are in the world, good morning, good evening, or good afternoon. Uh, I'm Omer Primor, and I'm iMvision's VP Marketing. So as I've said, this is the third of a three-part webinar series. We started very broad, talking about the broader business perspective in which security leaders today address application security in the organizational context. Then we dove deeper into the application security standards and how we restructure our application security programs to enable greater visibility and control. In today's session, we'll be talking more specifically about the individual to look at today's application security leader and the things that you need to know in order to secure API, to conduct and influence secure API development and be more relevant to the organization doing so. At this point, I would also like to thank our media partners for this series, the Fast Mode, for their continuing support in producing this webinar series. Before we begin, just a few words about iMvision. So iMvision helps organizations, helps enterprises to open up without being vulnerable, helping security teams to protect their APIs wherever they are throughout their life cycles. Our full lifecycle API security platform helps the security teams to discover their APIs, test them for business logic vulnerabilities, and to protect them during runtime up to prevention, and conduct all of that in one centralized place to provide ultimate visibility and control to prevent data breaches and sensitive data exposure. For today's session, I'm extremely honored to have a distinguished panel of professionals here with us today. We'll start with Laura Heritage, who's a true industry expert on digital business transformation, API lifecycle, and microservices. And today she's the VP product line for API management platform and open banking at Axway. Next, we have Owen Fleming. Owen brings more than 20 years of experience in security from multiple verticals, and today he's the Chief Information Security Officer at Leveris, a cloud-based retail banking platform provider. Next, we have Moshe Tzioni, who's the Director of Threat Research for Akamai, where he's responsible for innovation and threat detection roadmaps for Akamai's cloud security platform portfolio. He's even listed as one of the top influential penetration testers in 2020 by Peerlist. Last but most definitely not least, we have Michael Farnham, who brings close to 30 years of experience in IT and information security, and is today the CTO at Set Solutions, a cybersecurity solution provider and integrator. And he has also graciously agreed to moderate today's panel. Michael, over to you. The floor is yours.
Thank you very much, Omer. Really appreciate it. Excited to I don't want to say lead this panel because nobody can lead this panel, but definitely introduce this panel, bring it together. Thank you for bringing us all together. As Omer said, everybody, good morning, good evening, good afternoon, wherever you are in the world. Really happy to be on here. I'm going to start very quickly with just a few slides and talk about how we're going to bring all of this together, and then we'll talk to everyone on the panel individually. So let me real quickly share my slides, and then we'll get started. So I come at this from, and we've been talking sports and here before prior to us kicking this off, and I like to come at this from the perspective of playing a good ground game. Since we're talking about this on the individual level, what each one of the groups within the individual or within an organization can do to influence API security, we're talking about this at the lowest level. So I refer to that as the ground game. How do we play a good ground game? And what I mean by that is who are the members of the team and what do they have to do individually in order to influence API security? So in a traditional DevSecOps model, those each stand for developers, security, and operations. That's your team. How does each one of those influence security? How do they influence each other? How do they help each other and support each other in making sure that application security, and more specifically, API security, is functioning well within an organization? So some quick stats. This is some stuff from iMvision. The battle that we've got on that kind of that ground game is really, it's not necessarily a bad thing, but just coming at it from what the issue is API proliferation. internal APIs, if you look at this stats, the external APIs, there's all these high percentages of organizations that are already using APIs, either internally or business to business or business to customer. And those are internal and external facing. So APIs have already proliferated in so many different organizations. I would wager a guess that even these numbers are somewhat low, and there's probably much higher numbers of organizations that are already using APIs in the world today. And then once you see all of that high proliferation of APIs and the high use of APIs, then when you start looking at how that influences organizations and how that influences their deployment, APIs are supposed to speed up deployment. They're supposed to help deployment. But then if the security of those APIs and the development of those APIs is not good, then you're going to start seeing a slowdown in production, which is not good. So in a DevOps world, you want that to speed up, and that can slow things down. And then when you compare it to traditional app vulnerabilities, API vulnerabilities, the mean time to remediation of those can be a lot lower. And we'll actually get into why some of that is in this discussion. So when I say ground game, you may have a team built, you may have people on that team, but that does not mean you are playing as a team. So what we're going to be discussing today is how do you play as a team? How do you bring all of that together? And what you'll see as we talk to each individual and come at it from the developer aspect, from the security aspect, from the operations aspect, is there are a ton of common themes that they tend to think are in their silo, but they're not. They cross the borders of the dev, sec, and ops. And I think you're going to see that as each individual talks about their perspective, and you're going to see common themes go through all three of them, and it's going to come together. And that's what we're trying to do today, is bring all of that together into a single view, and how do we support each other from the developer, security, and operations perspectives. So with that being said, I'm going to start with Mr. Owen Fleming. Owen is going to come at this from the developer's perspective. And I'm going to pull up a slide for you, Owen, and let you go through that, and then we'll talk about some questions.
Perfect. Thanks, Michael. I love the way you referred to the traditional DevSecOps perspective. Yeah, that tradition is probably may even be a year old now, maybe two. but
it's a fast world these days.
I get where you're coming from. The thing for me is that, you know, I've been doing security for 20 plus years. I was originally a developer. And then as you do, you move away, you know, you move further up the management chain, you get further away from the tin, and you forget very, very quickly what it's like to be a developer. But over the last 7 years, I've got right back in there. And I had to relearn some of the things that I thought were self-evident. You know, the elephant in the room here, I think, is that, and it's very simple when you think about it. What are development teams incentivized to do? They're incentivized to develop features and ship code. They're not incentivized to do anything related to security. So expecting them by themselves to come to this resolution that we need to have secure stuff isn't going to happen, right? So when you think about an API as your APIs, whether they are internal or external, if you think about them as the window into the soul of your application, if your soul is bad, you know, you won't have API security if when you get past the API into the application and you start pulling code, you start pulling data, if the application itself is poorly constructed, poorly secured, you're going to have a tough time, basically, right? So you've got to go back to, as Michael said, the basics, right? You've got to train the developers, number one. That's the most important thing. You get in early, you train them, you know, and this isn't rocket science. This is OWASP. This is, you know, OWASP has a fantastic set of security principles, turn them into a policy, all right? Train the developers on that policy. Get the developers on an OWASP course, the top 10, the basics, all right? And get them understanding first why security is important to them. Forget about everything else, to them, right? Once they understand that, once that basic understanding is there, Then incentivize them to develop secure code, right? So change the incentives. Think about it like an SLA. If you have an SLA, you will always meet the SLA even if the service is bad, right? So give the developers an incentive to develop secure code. Give them management visibility. Give them prizes. Give them, involvement, right? Turn them into security champions. So get in at the requirements phase. So we did something that this is somewhat European focused, but it works everywhere else as well. Privacy impact assessment and security impact assessment. So at the requirements phase, do the secure by design, privacy by design, security by design. Then when you get into the actual design phase, be at the architecture meetings, listen to what they're telling you, right? Look at the tools that they're using, look at the approaches that they're using, look at the models that they're using, right? And try and actually get in there and help them actually optimize those, right? Attend the ceremonies, right? The thing is, security isn't an ivory tower. In the DevSecOps world, you're part of the team, right? So you have to be there at the ceremonies to answer questions, to show visibility, just so they know your name and see who you are, right? Testing phase, which happens actually throughout this from the development process, SAST, DAST, IAST, whatever it is you're doing, make the developers do the testing from a security perspective, because that's the only way they'll learn, to do the right thing in the right way, okay? So the key here is to get the developers doing the security testing. That's what DevSecOps is all about. It sounds simplistic, but it is simplistic. That's the whole point. It shouldn't be complicated. Once you get the guys trained, or the guys and girls, once you get them trained, once you get them understanding why they're doing what they're doing, once you incentivize them to do it, and at the end, before deployment, you pen test, you make sure that what you're launching is secure, then actually, when you come to API security when everything is up and running and being developed, you're going to have a very good baseline on which to build your API security on. But if you don't have that baseline there, then doing API security by itself is not helpful. Okay? And that's really the cusp of my ideas, Michael. So I'll hand it back to the team, and if anyone wants to ask any questions or add anything to that.
So yeah, thank you for that perspective. You're absolutely right. I think a lot of the basics are there. It's starting with those basics. So you've talked about kind of building, and again, this is questions for Owen to answer, but obviously anybody on the panel is more than welcome to speak up on this. We really want to make it a conversation. But you've talked about building that it kind of is I guess in some words, is a process first, right? You need to start with the process before trying to get things in that are very specific to maybe AppSec, but building the whole program first. So can you dig into how you see the education of developers, that security education? I know it's a big deal, but how do you see it as an importance in the roles of making sure developers are educated in secure development practices?
Yeah, developers don't have to be security people, right? So there will always be security people. That's the second DevSecOps, right? But the developers have to understand, particularly, one of the challenges is developers tend to be language specific or architecture specific or vertical specific. You have front-end devs, mid-tier devs, back-end devs. You've got a couple of full stack guys. You've got Java people. You've got PL SQL people. You've got Kotlin. You've got God knows. You've got thousands of different languages potentially, right? And developers will typically see security from the lens of their language, their context, right? So you have to bring it up a level. That's why OWASP, for example, is very good as a starting point for training, because you start with the principles, and from the principles, you then look at very broad generic themes, the OWASP top 10, for example, right? You don't have to go, for most developers, you don't have to go below that level. For certain areas where you might be doing very, very high security code, or, for example, if you're coding an authentication scheme or something like that in Java, you might want to have specific training for those devs, but it doesn't have to apply to everybody. Everybody has to have the principles and the top 10 basically. But after that, you're free to kind of be more experimental, but everybody's got to have the basics.
Laura, you're on mute. Yeah.
I was just seeing that. Is there a way to bake this into the DevOps process for them so that we can remove some of the burden off of the developers?
Yeah, so typically you take the train the trainer approach, right? So it depends on which programming paradigm you use, right? So if you're using pair programming, it's kind of easier. You just train one of the pair, right?
Yeah.
You know, in a typical kind of, in a scaled agile environment, you'll typically have to train at least the cross-functional leads and probably one or two. You'd certainly, and by the way, don't forget to train the testers, all right? If you're using full stack teams, right, you're going to be training at least the Scrum lead, right? The agile lead, and probably two or three, maybe two testers and two of the developers. And also if you're using pair programming, yeah, but basically you want to train probably a minimum of 20 to 30% of the team to a fairly high level, and have them, you know, kind of proselytize or evangelize with the rest of the team.
Well, but what Laura is saying, it brings a good point, because there's a shift left, a big shift left mentality, and some people believe it's a philosophical approach. It's not necessarily, can't really be done in really, really large enterprises that are, you know, all over the world with a ton of different dev teams all around the world, because some of the people that are on here are dealing with large organizations that are international in scope. So what you're describing, though, do you think it fits? Does shift left fit that? Does leading these or making these developers where you're training the trainers, there's almost a little bit of a head-to-head. People are fighting the shift left, but at the same time, they want the developers to be the one that lead the security team. It's, you see what I'm saying? There's kind of a battle going on.
There is. And you know, look, as you scale up, I mean, one of the not so secret things about Agile is it doesn't scale massively well. That's why you have scaled Agile, right? And when you have large distributed teams, it depends, you know, every company does it slightly differently, but if you're working on individual microservices and then you're meshing them all together, you will at some point have a cross-functional team. The cross-functional team are the people you train first, because they're the guys and girls putting it all together, right? Now, you might say, well, it's too late when they're starting to put it all together. And to a certain extent, that's true, but you've got to start somewhere, right? And you start at the point where you're integrating everything, right? Ideally, you'd start at the beginning. You'll almost never have the opportunity to do that in a large enterprise across multiple geographies with loads of different teams, right? So you start at the integration point, and then you work backwards down towards the individual developers. And that takes a long time, right? For example, it took me 4 years to do it in my current role. So it takes time.
Would you say that the most effective ways to tackle the any specific group within those developers in order for get the 80% and not spending 4 years, maybe just waiting for that? Of course, that's the vision, but yeah, from the get-go, what will be the strategy to go for developers with that?
So you go for the low-hanging fruit first. You go for the teams that are developing the high-threat, high-risk aspects of your environment, right? You know, it's not an ideal way to do it. You'd want to cover everything, but let's be honest, you're not going to, right? So authentication, authorization, access control, data management, data discovery. Those are the 5 teams you want to get, right? After that, testers, definitely, because the more testers understand about this process, the better it's going to be for everybody, all right? After that, you're really in a kind of rinse and repeat and trying to get more and more teams on board. And what takes the 4 years is getting everybody on board. But you don't actually have to do that. You're effective after about, let's say, 30%.
Great. Well, that's a good overview, Owen. I think we've covered that pretty well. So I want to try to jump over now to Moshe and talk about how that developer goes into security, how they support each other. So Moshe, if you don't mind sharing your slides, and we can start getting into your vision. and we can see your slides.
Yeah, can you?
Yes, we can.
Okay. So hello, everyone, and thank you for this opportunity to talk before you. Special thanks, of course, for the moderator today and the panelists, and Omer for joining us all together within this panel. What I'm going to discuss today is the effects of API security, specifically because of API, it's why we are here, but throwing some numbers around, which will be helpful to get to the point. I'm going to focus on, first of all, what is the difference between API security to normal web application security? So first of all, what we see on the platform, we see a ratio for about 1:8 of API to normal HTTP traffic, meaning that this is a very high ratio. We would expect it to be proportional to the population of traffic, respectively for HTTP and API, which is much, much lower ratio. So this is first sign of something that is attractive for attackers to test, at least, I won't say attack, to test and to investigate. The second thing that we should take into account is that we approximate that 20% of credential abuse attacks are used via APIs, which again, a very, very concerning number just to think about it. More of 22% if you look at the numbers for a second. The third item on the slide is more of a holistic number. 66 organizations reports that the actual development that Owen just talked about, the development cycle was slowed down because of an API security concern, specifically around APIs, which again gives you the breadth of how dire is this problem and how common is it to approach. And finally, on this list of numbers that are thrown at you is the 91% reported of discovered vulnerability in a production API, which again, I won't say surprising as a security person, because everything has a bug, right? Everything that is humanly created, it will be, sometime you'll find a bug, but a vulnerability is more than a bug. It's a bug that can be exploitable by an audience, by an attacker, by someone random, or by someone persistent that is locked on you to get as much as they can. So this is, to say the least, concerning. What we also see is some fluctuations on what vertical are you in. All the verticals are suffering from this fact, but especially on the numbers that we talk right now. So CRAB, credential abuse, is something that we see all the time. Leakage of data. It's something that we see a lot of approaches from attackers to use APIs to leak data. And we'll get to the why in the next slide. The final thing to note is that we are seeing more and more API traffic, which is normal. I won't say attacks. API traffic is normal. We see more and more migration towards API. More and more third parties are using APIs as a platform for expansions. So this is not going to stop the trend. Next, as defenders, what are the challenges for API security? So first and foremost, we are viewing that as an inventory control problem. We have a lot of APIs. We are producing more API that we know of. Any kind of system, ask any IT guy, do you have a current mapping of your IT organization? He would say, yeah, sure, but I'm not sure that's correct, which is a different scale in terms of API. Because you have so many of it, and you can't even control all of the APIs. You get so many third parties APIs within packages, libraries, I'm not even discussing test API that someone forgot online, which is something, of course, that happens from time to time. So first of all, it is an effective challenge that we want to control the enactment of security over those APIs. If we don't know about it, it will be much harder to control it and to secure it. You can maybe employ some kind of a broad security control over all of your website, but it won't be the same as, and it will suffer from false positives, meaning that you will catch something or block something that you don't want to block. Second, APIs by definition need to be functional. And by that means that it will be open up to much more of an intrinsic operation and elaborate in terms of data control, maybe exposing some of your inner functionality outside by intention. That is why APIs are for, to use it as programmatically as you can by a first or third party. The third action that also Owen have touched upon is that API security is all about developer education. At the end, I'm not saying that they are they hold the sole responsibility for it, but developer education shows that it greatly affects the overall security of the program. And now there is some progress on specific API security, which I would like to mention, is the OWASP Top 10 for API. I don't know how many of you even know about this API because it was written in 2019 and it's still a draft. Still, I would recommend looking at it because it is much more focused on APIs, and it puts in order of priority in order of commonality, excuse me, of what kind of API vulnerabilities we're going to find out there. And lastly, why attackers are loving APIs. Because of the same problems the defenders have a tough time with it. That's the short answer. So API discovery is hard for defenders, but I won't say it's easy for attackers, but attackers need to find them quicker than you can defend against them. And by that, use those under the radar API endpoints for their advantage. Second, as we said before, the functionality of those APIs are really attractive. And also they need to be accessible. So that in combination gives a lot of, the imagination will fly for attackers to see what can we exploit from those kind of two facts, functional and accessible. Lastly on the list, attackers' tooling have been progressed and evolved over the years. I would say even exponentially evolved. I remember maybe 15 years ago, 10 years ago, you would find some pen testers that know about APIs and how to control, how to attack specific APIs. There was SOAP at the time, there was REST. And now you find it in every kind of pen testing because they know this is a lot of advantage. And this is some kind of a common knowledge. The community itself, the hacker community, also expanded the common knowledge of those hackers and everyday attackers or pen testers. And by that means at the bottom line, you have an asymmetric war game going on with a disadvantage on the defenders and an advantage of the attackers on this war game. With this very fun note, I will stop here and let you, of course, ask questions.
Yeah, I was looking for some grain of good news in that, Moshe, but I'm having trouble finding it. But it does lead me to one of my questions. So you've spoken about APIs being functional in nature, which absolutely makes sense. They're not really something that anybody goes and browses like in a web GUI. They're there for a particular function. You've spoken about them being the higher level of traffic for APIs being focused on attacks versus a web GUI, which again makes sense because they're functional in nature. But to bring that together and talk about the theme of what's good news and what's bad news, because we've made so much progress, I believe, looking for that grain of good news in this, we've made so much progress over the years of getting better at traditional application, there's that word again, Owen, traditional application security, that do you think with the focus on education around application security in general for developers and code security, that hopefully we catch up a little faster when it comes to API security going forward, or do you see this asymmetric advantage for attackers being there longer?
That's a great question. So first of all, to answer your question directly, yeah, I do see a much more optimistic future for API security. And I will start with that. This session alone, or those session series alone, proves that there is an interest and awareness for API security. So this is one thing that we should remember. We are here because we know it's a problem, and now we want to tackle it. And that's a great step forward of where we are. And I will even say that those kind of discussions have been evolved. So if in 2019 we had an OWASP list for that, that's not the only thing. I just mentioned one thing, but that's not the only thing that was going around. There are multiple books about API security specifically. There are even some conferences about API and API security. And the hacker community, as I said, the hacker community is partly on the corporation as well. So you'll see much more evolution there. And finally, many companies, including Akamai, but others as well, are developing or having those kind of functionalities to help developers, to help corporates to defend against APIs. Again, specifically, if we are talking about a web application firewall, so you will have a component or components for API security specifically, and by that we'll see an evolution, and we will see toppling of this kind of leverage from one side to the other. That's beyond that. That's the direct answer. The indirect answer is that we do see some waves of, we need to see the projection of attackers and what kind of tooling they are projected. And in a given time, there is a movement, for example, for adversarial machine learning approaches that corporates knows better usually than attackers to operate under. They have the capacity, they have the advantage of more people working on these problems, which the hacker community is struggling to get. I won't say zero effort, but struggling to get right. And there is also one more advantage for corporates, is that they are flooded with much more data than what a single attacker or even a persistent attacker can have on their hands easily. So those kind of facts will eventually bring us to a better place in terms of optimistic approach, optimistic future for API security. Hopefully I answered the question.
Absolutely, that's a great answer. Thank you. Owen, Laura?
Yeah, if I look at what you said in terms of as you said, there's not a lot of good news here, but I think there's a key nugget of information, the discovery piece, right? The API security problem is kind of has its roots in the typical security problem of you cannot defend it if you don't know what's there, right? Mm-hmm. And you know what is scary, of course, is that in a microservices world, every single microservice that you have potentially has its own API, and it's being developed by an individual team, and you've got 50 of those teams, or you might have 100 of those teams, right? What advice would you give, in terms of controlling the sprawl, and particularly controlling, people getting far too creative, which I think is the biggest problem with what their APIs can do? Wow, a great question. There is a great quote I like to have handy from John Lambert. He's is another great hacker that said that the thing with defenders and attackers, defenders thinks in lists or checklists, and attackers thinks in graphs. So the best one-liner advice I would say that use those graphs for your advantage. You should think of your testing scheme as a graph, and by that define threat modeling. And how does an attacker will do that? To your point from the previous slides, once you have good developers and good security people, you can't expect good developers to be the best security people, and you are not expecting security people to be the best developers, and they complement each other. Because if one is really into the details of how machines work and how do they code their software, the other can complement the one with the way to think about it and how to attack that. One more thing that the corporates are long time doing is that having a red team, or sometimes called the purple team, to actually take the attacker's hat from time to time and try to tackle the operation. So I would say, think of the development team as a red teaming for your testing itself. You'll see a much more better view of how can we discover those APIs. Again, you can use the tools, you can use whatever we have in our arsenal, but eventually, if we're talking about education and collaboration between those teams and knowledge bases, which is a profession by itself, so that's why I'm saying no one can expect each other to really know everything. Maybe you have one unicorn in your corporation, but you can't expect everyone to have that. So if you get those approaches and then you actually act upon, meaning that you sometimes employ red teaming operations versus sometimes you employ the security by design operations, so you have those two complement each other. And by that, if you are thinking in graphs, that means that you would like to discover those APIs by graphs.
not by reading the documentation, which is a good approach. You can use the WSDL or something similar to have those kind of mapping. But eventually, if you won't have this kind of approach as the attacker approach, you won't have the complete picture to your satisfactory. And by that, you can actually, again, topple the scales in terms of you are going to be ahead of the attacker because the attacker will do the same. So this is what is meant to be in the hacker's mind. To have this mind is not enough. You need to act as an hacker. And by that, employ the same tools.
Laura, you got anything to add? That was a lot. So
yeah, no, it's all great information, and I agree with it all. Unless you can really find all those endpoints, all those APIs in your enterprise, you have no idea where your attack vulnerabilities actually lie. And let me caveat, when we talk about APIs, we're talking about the big APIs, not just REST APIs or SOAP APIs. We're talking about, event-driven APIs and all those different, when the API economy first emerged in 2011, we tried to redefine APIs to mean, business REST, but now I see it expanding back out. And I used to say, it's not my dad's API, but now we're expanding the definition of APIs back to my dad's API, because now we have the tools and the things to be able to manage all types of APIs the same way we manage those REST APIs. So.
Great. Well, Moshe, thank you very much. That was great overview, great details into your how you're looking at it there. And Owen and Laura, thank you for the questions and the comments. So now we are going to jump over to the operations viewpoint. So Laura, if you want to share your slide, if you're ready.
Yes.
And we can see those. Yep.
You can see them. All right. Again, Laura Heritage from Axway, and having the two great panelists before me speak, they just keyed me up for a slam dunk, and how we actually bring all this together, and how, when you look at your company and its full life cycle management, how it really all comes together. So first of all, I'd like to say congrats. You've successfully implemented your API strategy. You have APIs everywhere. I've worked with very large banks and health insurance companies, and you name it, all, and across all different industries all over the world. Back in 2011, we were just trying to get a couple of dev teams to build some APIs, to build some applications as a new way of doing it. But now we're up here where we have hundreds, thousands of APIs impacting hundreds of applications, both internally and externally, and creating several different attack vectors, as you just talked about earlier in the sessions. You're getting a major breach happens every 19 minutes. Hackers attack every 39 minutes. And these attackers, you really have to have that zero trust. These attackers can be internal to your organization, especially in a very large organization, and they can be external to your organization as well. So it's not just from one vector that they're attacking. Your attacks are coming from all different directions. Now, this is a typical API taxonomy from a large bank, and it's pretty much an example of a taxonomy of APIs in any enterprise today, where you have system APIs that expose data and algorithms. You have process APIs, and you have experience APIs. So you have multiple different vectors, multiple different APIs, multiple different protocols that you're dealing with. Now, when you lay that over, you don't just have one gateway, one enforcement point, one system that you're dealing with. What is happening is, now that enterprises have embraced APIs, they've embraced it in different ways, through different lines of business, through just the types of APIs fit certain gateways better than other levels of layers of the APIs. And so every enterprise are going to have at least 3, if not 4, different API gateways across their enterprise. Now, you as an operation person, you as a security person, how are you going to get control over this? Remember, we just talked about that. Moshe said you got to know where your endpoints are. You got to be able to see where your attacking is going to be. How do we bring this all together? This API complexity, just as what Ian and Moshe said, this API complexity slows us down, right? And we need to get a control over the complexity. And this is actually good news here that you have 3 to 4 gateways. At least you know what some of your APIs are, and you might be able to get into it and see it if you know those gateways actually exist, because most companies don't. I want to tell you one company that I work with, it's a large manufacturing company, has 8 different API management gateways within their organization worldwide, and they don't see them getting rid of any of them. They can't, right? And as an operations team, they have to get control over them. So the good news is, on the previous page, is that you have 4 different API gateways, right? So you're getting control over some. But there are those APIs that are not managed. So what about those? Okay, an average organization has over 650 APIs that are unmanaged, that are hiding, that are attack vectors somewhere. How can you build, like with the first panelist, Ian, how do you build that in? How do you get that, bring that tools and capabilities for the devs to automate the security, automate the location, so that that it just becomes automated to know that this API exists, right? Can you automate that? So the devs building an API that's going to be exposed, how can you automate that the knowledge that thing now exists, right? And as you move on and forward. Now, when you do this, we have to embrace complexity. It is here to stay. And you're really going to need to learn how to manage it. You're going to have to learn how to manage your event gateways that are event hubs that are exposing APIs. You're going to have to deal with multiple API management vendor gateways. You're going to have to deal with source code repositories where your developers might stick APIs that aren't being managed by any of these gateways. How can you bring those all together, put them in a single management plane, manage each of those environments, get them into a catalog so that you as an operations team can help your security officer and identify the potential attack vectors, identify the potential APIs that may need to be under control, under management by a gateway that aren't today. And so that's where I leave it to you and open up for questions. And basically, we can help you, everyone on the team here. It's about managing that complexity, embracing it, and getting yourself to be able to scale faster, more securely, and protect yourself.
Thank you, Laura. Really appreciate that operations perspective. It's finalizing it's obviously not the least, but it's at the end of this chain, and it's a huge part. I'm going to ask you a question that might start a war, at least on the outside. Maybe we won't see it because we're kind of isolated here, but having come a lot of my background from the network side of things, I tend to get the viewpoint of the operations team, have some insight from the development team perspective. But what we've tended to talk about here is that developers need to be educated more in security. That's kind of a common theme in secure coding. Does that translate? Does that security translate a little better for operations team in general? Is that something that they're used to or not? And you can stop sharing your slides too if you want to as well.
Yeah, let me stop the sharing here.
There we go.
There we go. That's a good question. I'm sorry, and I don't think security is fun. It gives me heartburn every time I have to put something in production and operations. So I think operations, are they more comfortable with it? No, but they know the buck stops with them. because they're the ones that are they're the ones managing all this data moving across all the different lines and having these systems up. They were supposed to interface with the security team and developers. And as someone that's done operations, it gives me, I have to embrace it. You have to embrace it, because the buck does eventually stop with you from an operations perspective. It's your data that you're managing, the traffic going back and forth. So
yeah, it comes back down to the incentives thing that we talked about earlier on. Operations are incentivized not to like security, but to do it, right? And they do it, right? Now, occasionally you get a deviant in the operations team who enjoys it. Most of the time you don't, right? But the key thing here is, the operations team inherently understand reliability, availability, and security, because it's actually what they are incentivized to do, right? And if we can get the developers on board with that as well, then I think it comes back to Michael's point about the whole team playing together, right?
Yeah.
You incentivize everybody. You have to incentivize them differently, because they're different teams and they think differently, right? But if everyone's working towards the same goal, it makes it a lot easier.
I love the point, Laurie. It is, having been in operations as well, when you get to that point where you've got to deploy, and especially in these days where not only is the application code, the infrastructure is also code. So you have to bring that into it as well. Now you've got code running the environment that has to be checked for security as well, all with APIs running under all of that. It's a different operations world. When I was in operations full time, I was still putting hard servers together, and there were a lot of pieces that I could check, and it was purely about configuration. Now it's down to code again.
Yeah, one of the things that I think helps the operations team, the problem is the operations team are always at the end of the chain, all right? And they get stuck, like developers, let's imagine, developers can develop whatever they want. The security people can try and control it as much as they want, but they'll never catch it all. Then everyone throws it over the wall, and the operations team has to catch it, right? And that mindset has to change, because you cannot have any expectation of uptime, availability, security. If you have, you gave the point, Laura, of having 8 gateways. Like, who thought that was a good idea?
Yeah, and it's not that they thought it was a good idea. It just happens in large, it just evolves, right? You're building a cloud native application on Amazon, right? On AWS. So the best gateway to use is an AWS gateway at that point, depending on what you're doing. If you're using a Lambda function, if you're building, you acquired an organization, right? They come with their own set of gateways. The level of effort to transition and get the buy-in and agreement to consolidate down to one gateway, I don't think it makes technical sense, because you should use a gateway that fits the need for the job that you're doing, right? You've got micro gateways, you've got edge gateways. You need to embrace the complexity, but manage it.
I think we can all blame. There was the famous memo that was sent. I think it was AWS actually, which was the beginning of that. I think that memo was everything will be an API. Full stop, right? And I think that can be traced to the root of that has created this problem. But
it's a good problem. It's a good approach to have, because we've embraced that at Axway as well. About 4 years ago, and when you do embrace the APIs, and as long as you get your security under control, right, on how you secure those and protect yourselves, you can really accelerate your development. You can accelerate delivering the capabilities that your customer or your business needs, and you can make changes easier. It's really, but you got to get control of the complexity first and make sure your security is solid. So congratulations on your successful API strategy. Now control your complexity.
No, I think we're
and
just
security.
the ops team as usual.
Yeah, typically how it is.
What did you change on the network? It's your fault. Yeah. O'Shea, what do you have any comments?
Laura, I can't get over the fact that I heard some shots fired once you said security is no fun.
See, all this gray hair is because of security.
I see. So my securities are kids. So, but in any case, the fun part of security is not there yet. Let me maybe put it elsewhere in terms of API. And I think that we can do a lot to make security fun again. Specifically on APIs, APIs are terrific, are very interesting, are very intricate, shouldn't be just a thing that we see as a gray area or gray functionality that we want to use. And developers are already there. In terms of this is the next step. This is what developers usually want to do, and backend and full stack and stuff like that. It brings us to another level in terms of use that it's fun. Now, I think in security, in the other end, because of this headache that we have with controlling all of that and the complexity of all of it, I think we can at least agree on the thing that we do see these complexities come to a plateau sometime. And by that, try to envision a way that we can minimize those complexities, either by from the get-go, meaning that we know that there are complexities, so we are trying to minimize them once we are designing something, or or as you said, getting this into our equation. This is a fact. Now we need to deal with it. Maybe what do you think? Is there something else you would like to have as an advice how to lower the complexity?
Yeah. As far as going back to the security isn't fun, and I am going to give a plug to Envision here about the AI-based security and the capabilities that they do bring to bear. I do think, and what you mentioned it as well, that AI and machine learning is going to give us, hopefully bring us on more of an equal playing field with the hackers and being able to resolve those attacks that happen and resolve them quicker than we are able to today. So that's very, very interesting.
I agree with that. So team, we are close to the end here. I do want to give a little bit of time for any questions that have popped up. If anybody has questions, I think we've got about 5 or 6 minutes. So there's a good question that popped up in the chat during this early on, actually, from David. So I want to read that, and we'll try to tackle this in the 5 minutes that we have left. So I have heard that it takes an average of 270 days to discover a breach. And Laura, this may go to just what you were talking about. What are you doing to lower that average? I can throw that over to you, Laura, like everybody does the operations, or we can try to tackle it in general. But I think some of it, in my mind at least, goes to what you were just talking about, which is some of the math that we've put into this to try to figure this out. Yeah,
well, maybe I should throw it over to Omar to answer it. But the easiest way that I've thought about it in the last couple of years when dealing with AI-based security, API security, is really thinking about it in terms of, credit card fraud, right? Where if your credit card company sees that you're all of a sudden buying items in Ireland and San Francisco at the same time, something is wrong. That's not your normal pattern. We need to be able to identify those patterns with our API usage. And even from, when a user's credentials gets hacked, they're making normal API calls. So there's nothing abnormal about that. It's not a OWASP thing. It's really somebody's got your credentials and they're buying something in Ireland when you're in San Francisco. And we need to be able to identify that type of information. We need that type of AI-based security on top of all of our APIs, both internally and externally.
Yeah, I'd back that up. I mean, the challenge that we really have from a security perspective is APIs are designed to extract information. That's what they do most of the time, right? And so an attack looks exactly like a normal use of the API. It can look exactly like it. So 270 days, I think, in terms of, you know, as an average amount of time to discover a particular breach, I would even argue, you see, that research is based on the premise that you understand that you've been breached, right? Most of the time, and this is not just APIs, you only know what you know. There are lots of breaches that happen that are never discovered, right? So 270 days as an average to discover a breach, I think, is very optimistic, scarily enough, right?
And a lot of times you only discover the breach because the hacker revealed that they took your data, right?
Yeah. Which is just, you know, that's kind of taunting you, right? So I think the key here is that, coming back to your point, Laura, and I think it's something that Omer might want to stick his oar in on as well. You know, there's so much traffic across these APIs, no human being can actually discover this, right? So you have to have some form of machine learning, something to detect patterns, something to detect anomalous behavior, because there is absolutely no chance, because it looks so much like normal behavior, that you'll pick it up in a standard sweep, basically.
I would like maybe to add to Owen's point that it really depends on the definition of normal. If we are looking at API data payload, that's where the fun begins, meaning that we can actually profile that, we can try to evaluate what is an anomaly, and there are so many approaches to this, and research papers covering how to find those kind of anomalies and what is important. Of course, you can take an off-the-shelf solution, and anyone here will tell you there is a solution for your problem in terms of anomaly detection and in terms of machine learning that will support you as well. And Laura said it, and I totally agree. The machine learning approaches for corporations are a thing that we should harness as much as we can. And by that, bringing it back to the definition of normal, normal is what you're supposed to see. And if we are not, even if the traffic looks the same, meaning volumetrically looks the same, you still have the power to determine what is a normal profile of your traffic. The second part is, of course, that you can see it on the time domain, and you can see it in the volume domain in terms of traffic, and by that also try to evaluate what is normal. So there are several approaches to tackle the recommendation here.
Omer, we're at the end. I know we've got a few more questions. Maybe we can tackle those offline, or I think we probably need to be respectful of everybody's time here, though. That was a great question, and obviously I knew it would take a little bit of time. So, Omer, I'm going to hand it back over to you. I will say, just as a close, that those common themes definitely came up. We saw things around proliferation discovery. APIs can cause slowdowns, even though they're supposed to speed things up. Developer education and getting developers involved in that process and shifting that to the left and helping them and support them. Bad news, but good news, I think, all the way around, that this is going to get better quicker than what we've seen in the past years. So very excited about this. Omer, thanks for having us. Moshe, Laura, Owen, great talking to you today. This has been fantastic.
Just one thing before all of our attendees drop off. Everyone, once you close this window, you'll have a survey pop up, 3 easy questions, just so we can get feedback, do better, and deliver even better content next time. Guys, this has been incredible, super insightful. Thank you so much for so openly sharing from your expertise, experience, knowledge, and know-how. Much appreciated, and I can see from the comments in the chat that a lot of people agree. So thank you, and to everybody, have a good night or a great day if you're just starting out. Thanks.
Thank you.
Thank you, everyone.
Thank you.
Thank you all.
All right, bye.